So hello guys, with the name of God Ram Ram. Today we are going to enjoy the problem C, whose name is Risky Tower. The problem was asked in Codeforces Round 1115 Division 2.
Hi everyone, this is Yashasvi. I am a third year college student and I've recently cracked Google internship. I did a step internship in this summer, which is 2025, but I got a PPI and I'll be returning again in 2026 as a SUI intern at Google.
So guys, before we begin this problem, there are few things which you should know in advance that makes things easy for you. Okay. First of all, you should have done some grid or matrix based problems. Okay, this will really help you a lot. And second thing is you should know how sorted multisets work. Okay, basically sorted multisets are a kind of data structure which can handle all the elements in a sorted manner, and then we can do some insertions, and we can also remove some elements from the sorted set. Okay, so if you know these two things, then solving this problem is just a piece of cake. Now this problem is actually very easy, but still many people face issues with this problem. So rather than directly telling you the solution, what I will do is that we will try to explore it in a human fashion. Like if we are a normal person trying to solve the problem, what things will come in our mind first, and what should we do when those things come in our mind. So that way you will learn actual problem solving skills. Okay, so the question is saying that you are given a matrix, and you can just select some elements of the matrix and destroy them. Okay, now while doing this procedure, if special value of any column becomes less than equal to 0, or if all the elements of any row gets destroyed, in that case they are saying that the procedure will stop. You can stop doing the procedure. Now you want to do this procedure in minimum number of moves. Okay, so I'll try to explain you what they're saying. They're saying that a matrix like this is given to you. Okay, let's take this matrix like this, and this is M and this is N. So this much is clear to you, it is clear to me as well. So Ram Ram, the thing is that for each row na, a special value is given. So let's call this value as 5. Let's call this value as 100. Let's call this value as 200, and let's call this value as 300. Okay, for each row a special value is given to us. Okay, and in matrix all the guys do have some values, right? So let's say this is 8, 1, 8, 2, 2, 4, 1, then 1, 3, 2, 1, 1. Now they are telling us to select some elements in this matrix such that either some row gets deleted. Basically at max you can only select 3 elements. Why? Let's say you try to select this element, this element, this element. If you select 3 elements, this row will get deleted, and as soon as a row gets deleted, the problem is solved. So guys, let's try to write the explanation, understanding of the problem. Select some elements from the matrix of size n cross m. Okay, while doing this procedure, so these are the steps of the problem. Select some elements from the matrix of size n cross m. If once the element is selected, it gets removed from that row. Okay, the next thing, very simple guys. Once the element is selected, it gets removed from that particular row. If any row has 0 elements, then stop the procedure. Apart from that, if special value of any row becomes less than equal to 0, then also stop the procedure. Now I'm writing in note, each row is assigned a special value. So these things are clear in your mind, my mind also. Now guys, one more thing is there. When you select the element, let's say you select the element a of I of j, then what happens is that all the rows from all the rows from index 1 to I gets a deduction of aij in their special values. So I will show you how this rabbit hole goes. Okay, so guys, you know that you can solve this problem in 3 moves. How? Select this guy, this guy, this guy, and this full row is deleted. If any row gets deleted, our problem is solved. But you can select these 3 guys also for deleting 1, 2, and 3. See, this row got deleted, problem done. Or you can select these 3 guys. So guys, you know the answer can always be M. You understand the fact that answer can always be M, right? So why are we not just printing M? You know one possibility is simply M. There are multiple possibilities for the answer, but one clear possibility is M. We understand that, okay? But guys, what if you can get a better answer than M? If you can do less than M operations and still you will be, if you are able to stop doing the procedure in less than M steps, then yeah, you won because you wanted the minimum number of steps. So guys, I will show you, I will do this full procedure in just 2 steps. How? This is what I will do. First, I will select this guy. I will select 2 from here. So if I used 1 based indexing, 1, 2, 3, 1, 2, 3, 4. So if I select this guy, it means this guy is getting deleted. What guy I have selected? The name of the guy is A of 4 of 3. A of 4 of 3. Okay. Okay, sir. Okay. So as you select this 2 now, what happens is that 2 will be subtracted from all the special values from here till up. Okay. So 300 minus 2 is going to happen. 200 minus 2 is going to happen. Okay. Obviously. And 100 minus 2 is going to happen. And 5 minus 2 is going to happen. Then what will be the values? This will be 3. This will be 98. 198. And this will be 298. That's it. Clear, guys? So guys, do you understand when I delete an element, I subtract this value from all the rows which are coming above me, including my special value of my own row, which was 300. So guys, this element has been deleted. Now, which element I will delete? Now I will delete A of 3 of 3. And what will happen? If I delete this guy now, what is going to happen? All the special values from here till the top are going to get minus 3 in their answer. So current special values are these, this. Okay. So only those special values will be affected which are the rows where this 3 is there and all the rows above you. The row below you will not get affected. So only this value will be getting minus 3, this minus 3, this minus 3. So what will be the output? 3 minus 3 will be what? 0. 98 minus 3 will be what? 95. 195 and 298. And now the procedure stops. Why? Because if any special value becomes less than equal to 0, see, this special value has become less than equal to 0. If any special value becomes less than equal to 0, guys, then you stop the procedure. There are 2 ways to stop the procedure. Either you destroy all the elements of a row like this, or you select elements in such a way such that one of the special values become less than equal to 0. You can make multiple special values less than equal to 0, but even if a single special value becomes less than equal to 0, your job is done, and done. So in 2 steps, you are able to achieve this thing. But guys, you can do this procedure in 1 step also. Try to think how can you do it in 1 step. Pause the video and write in the Google chat how you can do it in 1 step, and then I will tell you the solution. So so let's go back to the original question. This was the question. Let's remove this part. How could you have done it in 1 step? Let's think about it. To do this lovely thing in 1 step, let's just cut this 2-step solution. You can do it in 1 step, and 1 step is the best answer. Final output is 1. To do it in 1 step, you can just select A of 1 of 3 and the job is done. Why? If I select this element and cut it out, all the rows special values will be affected, which are including this guy and above. So only this will get affected. Only this 5 will get affected, and what will be getting subtracted? 8. So it will be 5 minus 8. 5 minus 8 is what, guys? Oh my goodness. Oh my goodness. 5 minus 8 is minus 3. So this value has become less than equal to 0. This 5 has become minus 3, and the other values are 100, 200, 300 only. They did not get affected. But even if a single special row value becomes less than equal to 0, your procedure stops. So you're able to stop the procedure in just 1 move. So guys, this is the problem. Now how do we approach? Let's see what the human approach would be. Humans would try to think in this manner only. And when you come to know that this method, like from this method, we will go towards the right method. So what will first come in your mind? That okay, I have to do the procedure. So what if I can do linear search or binary search on the number of moves I can have to make? Can I do that? Let's try to see whether it is realistically possible or not. Okay. One, two, three, four, five, six. One, two, three, four. You know that all the special values are nothing but greater than zero. All are positive numbers, right? All these numbers are just positive numbers. Okay. So if someone told you that, hey, just try to make one move, try to solve the entire thing in one move. If you are not able to solve it in one move, then let's say try to solve the entire thing in two moves. So how would you generally approach this if someone told you that, hey, do everything in just one move? So what can you do? You will try to think, can I destroy this? See, first of all, one option you will fix in your mind that M is one of the possible answers. Apart from that, if you want to solve the entire question in one move, what you will have to do? You will try to think, can you destroy this, can you destroy the special value of this row in one move? How can you destroy this in one move? You can select any element in the whole matrix. So you will select the largest element in the whole matrix. Let's say you select this guy. What is it is going to do? It will create effect on this row also. This row also, but we are concerned only about the first row. So this value is going to get directly being attacking the special value of the first row. And I want the first row value to become less than equal to 0. So I will take the largest value in the matrix and I will select it. I'm only doing one operation. I will take the largest value in the matrix and I will make sure that hopefully it is able to destroy the special value of the first row because I have only one option allowed. What is the second option? I will try to decimate. I will try to destroy everything. Just give me a minute. Okay, now guys, listen to me. Okay, so this is one possible option. Let's say you are not able, let's say it is not working out. Selecting the largest element in the matrix, you are not able to beat the special value of the first row. Now what will you do? What you will do is that you will try to destroy, like try to make this special value less than equal to 0. Because if any special value becomes less than equal to 0, the problem is solved. Can you make this special value less than equal to 0 in one move? Which cells can affect this special value? Only the cells in the green region. So except the first row, you can select this cell or this cell or this cell. You either select this one or this one or this one or any cell in this green region. Any one cell you select, it will be able to directly affect this cell. Why? Because whenever you select this cell, it creates deduction in all the special values of all the rows till the top. So this is also going to get affected, right? So now guys, the question is very simple. If you want to destroy this special value, select the largest value in this green color part. Okay. Let's say you tried to destroy this in one move, it did not work out. You tried to destroy this in one move, it did not work out. Now you will try to destroy this guy in one move. For that, what you will do? Select the full matrix, including this row and all the rows below. Why? Because you can select any one cell in this green color part, and that cell will be able to deduct that value from the special value of that row, the row which is currently under consideration. So that's it, guys. You will try to destroy this. If it fails, try this, try this, try this, try everyone. If any one of them is able to get destroyed in one move, then one is your answer, baby. Guys, if one does not work out, you can try for two, you can try for three, you can try for four, and you can go towards the linear search and binary search solutions. But guys, can you see that this is giving us a generic idea of the solution already? Let's say someone tells you that do everything in one move only. So the solution is rather simple. Let's say this is 8. Let's say this is 18. Let's say this is 10. Okay. Let's say this is 12. Okay. 11, 1, 1, 1, 1, 1, 1, 1. You know that you can solve the problem in three moves. But let's say someone tells you do it in one move. So what you will do? Try to destroy this special value. You have to destroy 18 in just one move. It means In this whole matrix, you can select any one cell. What is the largest value in the whole matrix? 11. So 18 minus 11, still it does not become less than equal to 0. So even if I select this, it affects this, but also this guy. But this guy under consideration is not becoming less than equal to 0. It means 18 cannot be destroyed in one move. So now I will try to destroy the second guy. For the second guy, I can only choose the cells in this path, in this part region. Why? Because if I select, let's say, any cell outside of this region, let's say I try to select one, it can only destroy this special value or the special values above which don't exist. So I can only select from this region. So the biggest one is what? 11. 11 will, yeah, you are able to make it less than equal to 0 in one move. 10 minus 11 is a negative number minus 1. So yes. And if you try for 12, it's not going to work out. Why? Because 11, it goes there, but it's not able to destroy 12. So this failed, and this worked out. So yes, in one move, you can solve the problem. So guys, what is the generic solution of the problem? Generic solution is very simple. Then we will look towards the optimization for the problem. Generic solution is that solution sketch, try to destroy row number 1 in minimum number of moves you can. Note down that number of moves. Try to destroy the row number 1 in the minimum number of moves you can. Let's say it took G1 moves. Similarly, do for row 2. Let's say that required G2 moves. Final answer will be what? Nothing but minimum of G1, G2 till Gn. See guys, you will first try to destroy the first row in minimum number of moves. Try to destroy the special value. Try to destroy the special value of row number 1. And let's say that takes G1 moves. Then try to now forget everything and only focus on destroying the second row. Similarly, do for special value of row 2. And so on till for the special value of row 2. And guys, so on you will try for each row. One of the rows will give minimum number of moves. If you know, let's say the second, because here in this case, you know now, destroying the second row special value was the best option. Because first row and third row were not getting destroyed. If you are not able to destroy these rows, then the answer should be infinity. Like do infinite moves, then also this is not gonna die. Do infinite moves, then also this is not gonna die. So in this particular case, to destroy 18, all you have is these options: 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, yes, you can destroy 11, 12, 13, 14, 15, 16, 17, 18. You can select 8 elements: 1, 2, 3, 4, 5, 6, 7, 8. You select 8 elements from here and you just do your job. That's it. So yeah, you can destroy this guy in 8 moves, but this guy can be destroyed in 1 move. And 12, you can select 11 and 1 from here. So in 2 minimum moves, 12 can also be destroyed. So what is the minimum of all of them, guys? Minimum of all of them is 1. So 1 is the answer, because in 1 move by selecting this, it does affect 12, but it affects 10 directly, and 10 gets destroyed, it becomes less than equal to 0. Done. I done. Now listen to me very carefully. So guys, what is the brute force solution? Very simple. For any row I, what you will do? Now I will directly go into the deep trenches, okay? So let's say I want to solve this problem. This is M and this is N. So what am I going to do now? Let's say I want to see, let's say this value is, let's say this is row number I. And let's say its special value is R of I. So what you will do? I will push all these elements in the green region. I will push all these guys in an array. Like this guy, this guy, this guy. All these guys, I will put them in what? I will pull them in an array, push them in an array. Then what you will do? I will sort this array. And then what I will do? I will use its biggest elements. I will use the biggest elements of this array. Use the biggest of the elements of this array to attack R of I. And that will make sure that I am trying to destroy R of I in minimum number of moves. For example, to destroy 10, what I will do? All the elements in this part of matrix, let's put them in an array. So what will happen? The array will look like 1, 1, 1, 11, 1, 1. Okay. Now I will sort this array. 1, 1, 3 times 1, 4 times 1, 5 times 1, then 11. This is the sorted array. Now to destroy this 10, I will start from the biggest guy. 11. Attack. Done. It means in one move it is done. So guys, the logic is very simple. Time complexity, guys, see, for each row I, what you will have to do is, you will have to travel all these guys, right? So in worst case, it can be n into m elements. You push them in an array, you sort it. So n into m into log of n into m time it is taking for just one row. And how many rows can be there? There can be n rows, right? So you will do this for each of the n rows. So this is the time complexity, which is n square m into log of n into m. Now guys, we will go towards optimization. Okay, so optimization will just involve sorted multisets, and they are available in C++ easily, but for Java and Python you will have to do some workarounds. Okay, so let's talk about sorted multisets. Let's not forget about them. So guys, what you will do now, these guys are able to maintain everything in a sorted fashion. But to save space, you will only create sorted multisets of size m. Never create the sorted multisets of size more than m. That's what I want to tell you. I hope you get the point. You will understand, but for now, these guys are nothing but they look like this. See, 1, 5, 8. What you can do in the sorted multiset? You can do insert operation. If you insert 7 in this, it is not going to look like 1, 5, 8, 7. No, 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 no. It's not going to look like that. It will automatically insert 7 at the sorted position. 7 should go between 5 and 8, right? So if this is your sorted multiset S and you do S dot insert 7, then it will look like 1, 5, 7, 8. Also, you can always get the largest element and the smallest element of this set. Okay. So insert operation takes log n time, where n is the number of elements in the current set. And largest element, if you query, it will give you 1. Smallest element in the current set, it will give you 8. These largest and smallest query also take log n time, or roughly O of 1 time. Actually, it takes just O of 1 time. And insert operation takes log n, O of log n time. You can do delete operation also. If you delete 5, this sorted set is going to look like 1 comma 8, and deletion also takes log n time, where n is just 3 in this. So you will say, sir, how is the sorted sets helping us? Well, what you will do is that as you are going up, you know that in this type of question, you know that the answer should never be bigger than 3, right? But aren't we doing time pass by, for example, let's say you want to solve for this row I. You are storing so many elements in the array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You are storing 15 elements. You are sorting 15 elements. But can you see? You can only use 3 largest elements to attack R of I. If you try to use 4 or 5 special elements, you are wasting your time, because answer can never be bigger than 3. Why? You can just select any 3 elements and delete any row now. Don't forget that. So what you should do is, for this, to save space and time, generally speaking, you should maintain only the 3 largest elements of this part of matrix. This blue color, you should only store what are the 3 largest elements of this. Let's say this is the largest one, L1, L2, L3, such that L1 is greater than equal to L2, greater than equal to L3. Now only use these 3 guys one by one to attack R of I and try to make R of I less than equal to 0. Why? Because if you use more than 3 elements, anyways you're missing the target. Answer should never be greater than 3, because answer can always become 3. So try to get answer as 1 or 2. So only use 3 largest element. Either attack with the 1 largest element, or the 2 largest element, or the 3 largest element, but don't do more than that. Let's say you are able to defeat it by 4 largest elements. It means you required 4 operations to do it. But you could just delete it in 3 operations also, this row, without touching the special value of that row. So don't forget it, bro. Don't forget it, okay? So guys, how can you maintain only the 3 largest elements for any matrix which you want? So you can do some observation. What observation you can do? You can maintain m largest elements in a sorted set. M largest elements in sorted set for each matrix, you want. How? I'll show you guys, I'll show you. Let's say this is your matrix, okay? First you try to decide to kill the bottommost row, okay? Let's say it is like this. Okay, we let's say we come down and this is row number n, okay? This is m and m is 3. So you only want to maintain 3 largest elements, right? Let's say this is 5, 8, 10. Let's say this is 11, 3, 2. So when you're trying to destroy this R of n, you only store these elements in your sorted set, these 3 elements. So your sorted set will look like 5, 8, 10. Now you can just travel this sorted set from the largest element and you can try to attack R of n, because you know na, R of n only cares about this much matrix. So this problem is solved. When you come here, let's say now you're trying to destroy R of n minus 1. You know that you try to destroy special value of each row. But for R of n minus 1, they want you to consider all these elements. So what you will do is 2, 3, 11, right? You insert 2, 3, 11 in this. So what will happen? It will look like 2, 3, 11, right? So 2, 3, 5, 8, 10, 11. But guys, we only want 3 largest elements. So now I will delete the 3 smallest elements from this matrix. Delete 3 smallest elements, what will happen? 2 got deleted, 3 got deleted, 5 got deleted. So 8, 10, 11. So guys, when I'm here, I inserted these 3 guys. I got this new sorted set of 6 elements and I again deleted 3 elements from it, which were the smallest one. So 8, 10, 11 are the 3 largest number in this part. I will use 8, 10 and 11 to destroy Rn minus 1. Why? Because you never need to use more than 3 elements. If you use 4 or 5 elements, then you're already losing, because any row can be destroyed in 3 moves. So in this part, the 3 largest guy are 8, 11, 10, and that sorted set is able to maintain that data. Wow, wow, wow. Now guys, I will stay silent. Let's say you want to attack R of n minus 2. And let's say this value is x1, x2, x3. What you will do? Insert these 3 values. So what it will look like? 8, 10, 11, x1, x2, x3. We don't know what is x1, x2, x3. Once you do the insertion, what you will do? You will remove the 3 smallest elements. x1, x2, x3 will be in the sorted order automatically. You remove the 3 smallest elements from here, and automatically this set will now have the 3 largest elements in this much part of the matrix, and you can use those 3 largest elements to attack Rn minus 2. Wow, wow, wow. Such a lovely observational constructive algorithm and data structure sorted set problem. Just love it. So guys, what will be the time complexity this time? Well, if you talk about the time complexity, what are you doing at each row? At each row, I am inserting these m elements in the sorted set. So for this row n, I insert this, right? And so inserting m elements will take m time, right? Yeah, m of log m time. Okay. And at this row, what I'm doing, I'm inserting this element, but at the same time, I'm removing m elements also. So generally speaking, you are doing 2 times m log m operation at any row I, because if I am at this row I will insert this guy, this guy, this guy in my sorted set. My sorted set will become of 2m size. Then I will again remove the m smallest elements. So m insertions I did and m removals I am doing in all the rows. But in the first row, I only did m insertions because there were not enough elements. There was nothing to remove there, right? So 2m log n for each row. And so there are n rows. So n into 2m log n. So which is 2 into n into m into log of nm. Sorry, into log of just m. So which is nothing but O of n into m into log m. And the problem is brilliantly solved. Let's try to check the implementation one time. Make sure you like, share, and subscribe, guys. So guys, this is my code link and let's check it out how it is going. You can guys see n and m, the special values taken in the input, took the input of the matrix. Now traveling it from the bottom, I go to that bottom row, whatever is the, sorry, I go to the current row. I insert the elements of the current row. If my size of my sorted set is greater than m, I will remove the smallest element. So that sorted set only has the m largest elements. Okay. Now what I will do, I will travel the sorted set of m elements and I will take its biggest elements. I'm traveling the sorted set, multi-set in reverse order. I will take its biggest element and I will try to kill the special value limit equal to v of I. As soon as the limit becomes less than equal to 0, it means I've killed it. How many elements were required to do this is stored in count because count is getting incremented. Answer equal to min of answer count and it is done. So hope you guys enjoyed this session. Love you all. Ram Ram.